Hello everyone. Today we are going to talk about the application of AI technology in automobiles. The so-called AI is the abbreviation of artificial intelligence, which is what we often refer to as artificial intelligence. So what is artificial intelligence? Is a new technical science that studies and develops theories, methods, technologies, and application systems used to simulate, extend, and expand human intelligence. It is an important branch of computer science. When it comes to artificial intelligence, everyone should remember a man-machine war that attracted widespread attention around the world a few years ago. This competition was called Ultimate Showdown between top human chess players and artificial intelligence. In the competition, representing humans was Qi Jie, a Chinese player and the youngest five-time champion in the history of World Go, and his opponent was AlphaGo, a Go computer program developed by Google. The final result of the competition was that Qi Jie lost to AlphaGo with a score of 0-3. Before that, AlphaGo had also defeated Lee Sedol, a top South Korean chess player, with a score of 4-1. Through these two-man machine wars, people saw the huge potential of artificial intelligence. In recent years, the development of artificial intelligence has been very rapid, and it has long been imperceptibly integrated into our lives. For example, intelligent voice assistants can talk to us and query information such as weather and flights. Face recognition, based on a large number of pictures, has opened face recognition checkpoints at railway stations, airports, and other checkpoints. Face unlock and payment on mobile phones, face verification in bank finance, etc. There are also recommendation systems based on user behavior data. For example, product recommendations and hot news pushes in commonly used apps often recommend content related to us and that we are interested in, all of which use artificial intelligence technology. There are more fields that also use artificial intelligence, such as unmanned driving, smart medical care, artistic creation, and robots. In this era of the Internet of Everything, it can be said that artificial intelligence has penetrated into every corner of our work and life. As a very important means of transportation in our lives, automobiles are inevitably inseparable from the support of AI technology. Artificial intelligence has a wide range of applications in automobile R&D, supply chain manufacturing, sales and after-sales services, and unmanned driving. It can be said that the development of artificial intelligence technology has had a disruptive impact on the automotive industry. It will also become the driving force for innovation in the automotive industry, spawn new formats and business models, and thus trigger profound changes in the automotive industry structure. Let's take a look at the application of AI technology in autonomous vehicles. It can be said that autonomous driving technology is an intensive application field of artificial intelligence technology, which is mainly reflected in voice and image recognition and perception, positioning technology, deep learning, information sharing, and other aspects. Due to the application of technologies such as artificial intelligence, we hope that future automobiles will be able to see, hear, speak, act like humans, and more importantly, think and learn. Let's take a few examples. First, let's look at the first one. At present, many automobiles can already realize human-vehicle interaction. For example, automobiles with intelligent voice systems can execute instructions and start operations after receiving task instructions. With the improvement of intelligence, cars can also chat with you and even discuss food, drink, fun, life, and ideals with you. When you are driving fatigued, it can also remind you to pay attention to driving safety. The intelligent voice system can not only simplify some operations during driving and improve safe driving, but also bring great fun to boring driving. Okay, let's look at another example of face recognition. This is the Great Wall Wave VV6. It can perform face recognition on the driver through the A-pillar face recognition system, automatically match the driver's ID account, and retrieve preset personalized settings, such as automatically adjusted seats and central control display styles. When the system detects the driver's happy expression during driving, it can actively push music that matches the mood. During long-term driving, it automatically recognizes the driver's fatigue level and recommends feasible service areas or parking lots based on the distance. In the process of these face recognitions, artificial intelligence technology is also indispensable. Third, let's look at an example of deep learning. Deep learning is an important branch of the field of artificial intelligence. In the past 10 years, autonomous vehicle technology has made tremendous progress, largely due to the development of deep learning, such as the application of deep learning in lane line detection. Lane line recognition is very important in autonomous driving. First, because lane line recognition exists in most scenarios of autonomous driving and is an indispensable basic algorithm for autonomous driving. Second, because lane line recognition can accurately identify roads and ultimately help machines make decisions. It is also an important guarantee for driving safety. Early lane line recognition mainly adopted traditional vision schemes. Although the operation efficiency is high, there are certain limitations. For relatively old roads with unclear lane lines, the recognition effect is not ideal. At the same time, traditional schemes are too dependent on light and can only perform well in sunny and unobstructed weather. However, in our autonomous driving scenarios and automatic mapping of high-precision maps, lane line recognition is usually required to be real-time and accurate, with a precision requirement of centimeter level. At this time, traditional vision schemes are somewhat powerless. Compared with traditional methods, deep learning methods have more advantages in various fields of computer vision. It can output accurate and efficient perception results for recognition targets through a large amount of data collection and sample training. In summary, the integration of artificial intelligence technology and the traditional automotive industry has brought a new intelligent terminal, autonomous vehicles. Based on artificial intelligence technology, autonomous driving of automobiles is realized through perception, planning, and control. It not only brings great convenience to people's travel, but also can bring considerable economic benefits to automobile enterprises and high-tech enterprises. At the same time, it will also create huge social benefits, such as reducing traffic accidents, improving road capacity, and reducing pollution and energy consumption. Part 3. Application Scenarios of Autonomous Vehicles. Hello everyone. Today, we are going to learn about the application scenarios of autonomous vehicles. We know that driverless cars are the product of the deep integration of the automotive industry with the new generation information technologies such as artificial intelligence, high-performance computing, big data, and the Internet of Things, as well as multiple fields such as transportation and urban management. Data has a profound impact on reducing traffic congestion and traffic accident rates, helping cities build a safe and efficient future travel structure, and on the transformation of the automotive industry and urban transportation planning. However, the current level of autonomous driving development is limited by the level of software and hardware equipped on the vehicle itself and the level of infrastructure construction based on vehicle-road collaboration. Driverless cars are still far from real commercialization. Therefore, at this stage, autonomous driving is mainly applied in some limited and low-speed scenarios, such as logistics and distribution, shared mobility, public transportation, sanitation operations, ports and terminals, intelligent mines, and unmanned retail. Let's first look at the logistics and distribution industry. For a simple example, many of us like online shopping, and the things we buy will be sent from all over the country, which of course cannot be separated from logistics. For the logistics and distribution industry, reducing costs and improving efficiency are the focuses of major logistics companies. With the development of 5G communication and the Internet of Things, with the help of driverless technology, logistics operation processes such as loading and unloading, transportation, receiving, warehousing, and delivery can gradually realize unmanned and mechanized operations, promoting the upgrading of the entire industrial chain in the field of logistics and distribution. In China, commercial vehicle enterprises such as FOU, Dongfeng, and Sinotruk have launched driverless heavy truck tests. At the same time, enterprises such as Alibaba, Cainiao, Baidu, Meituan, and JD.com have also made progress in the application of driverless technology in the logistics field. For example, on the 18th of June, 2018, JD.com, quote, "S Delivery, robots officially launched the world's first full scenario normalized delivery operation in Beijing." Let's watch a video. From this video, we can see that the scenarios of unmanned delivery are very rich with a variety of models, which can realize multi-route circular delivery and greatly improve operational efficiency. They move freely on the road, accurately avoid pedestrians and vehicles coming and going and turning, pulling over. And passing speed bumps are all easy for them. When encountering intersections, they also stop at red lights and go at green lights. Isn't such a delivery robot very smart? The reason why it is so smart is that it applies many black technologies all over its body, including autonomous driving, visual recognition, and other technologies. The application of these technologies provides a strong guarantee for the robot to cope with complex delivery tasks and well solves the problem of the last mile of logistics and distribution. DIT will surely continue to improve consumers' delivery experience and help the promotion and popularization of smart logistics. The second application scenario is shared mobility. The shared mobility field includes two sectors: public transportation and taxis. Domestic enterprises, in the shared mobility field, such as Baidu, Yutong, and Qianlong, have all started application tests of driverless shared cars. On the 4th of July 2018, Apollo, COCO created by Baidu Apollo and Qianlong Bus, officially rolled off the production line in mass production, planning to carry out commercial operations in Beijing, Xiong'an, Shenzhen, Fujian, Pintan, and other places. On the 18th of January 2019, the multifunctional Panda intelligent bus independently developed by Deep Blue Technology was officially released at the New Generation Artificial Intelligence Future Development Summit, and the bus has been put into trial operation in Deyang, Changzhou, and other places. On the 22nd of January 2019, the first L4 level driverless, fully intelligent bus developed by China National Heavy Duty Truck Group officially started road operation tests in Shandong. In March 2019, Yutong's intelligent connected bus with L4 level autonomous driving made its debut at the Balfour Forum. Let's watch a video.
车辆已经启动了，正在缓慢地向黄河路行驶。当确认周围环境安全后，车辆会缓慢地驶入黄河路。那么整车的感知设备呢，是由40线激光雷达、毫米波雷达以及摄像头组成。它可以感知车辆前方0.2米至200米范围内的一切事物，保证车辆在行驶过程中至少前方200米范围内无盲区的一个检测行驶。那么我们可以看到，驾驶员在驾驶过程中呢，他不会去踩踏板，包括油门踏板、刹车踏板以及方向盘。好的，前方是一个绿灯状态哦。那我们在这里就可以看到，在我们规划这里呢，绿灯的一个剩余的时间是30秒，那我们就可以控制车辆继续按照目前车速呢平稳的行驶。好的，我们现在已经通过了这个路口。在这段路中，我们可以看到前方视野良好，没有其他的车的干扰。它的加速过程中呢，预期会加速到我们设置的一个最高的车速上限。我们设计的一个最高车速上限呢是40公里每小时。那么现在在加速过程中。好了，我们车辆在前方呢，即将到达本次试乘的终点站，车辆将会靠右边停车。车辆正在降速进站。
This Yutong intelligent connected bus has functions such as intelligent interaction, automatic cruising, lane changing, obstacle avoidance, overtaking, meeting, following, entering the station, as well as emergency braking, precise parking, intersection passage, and vehicle road collaboration, fully reaching the level of highly autonomous driving, which has won praises from visitors and experiencers. At the same time, this autonomous driving bus also shows the strength and charm of Made in China to the world vividly. Let's look at the taxi industry. Driverless technology is customized according to geographical location and provides onboard navigation functions under urban and dynamic conditions to help taxis realize automation. For example, on the 21st of August 2020, Baidu launched the Apollo Go autonomous driving taxi service in Hangzhou. Citizens and tourists in Hangzhou can call a robot taxi with one click through Baidu Maps and a ticket for free. In October 2020, Baidu announced that autonomous driving taxis are fully open in Beijing, and citizens can take free test rides at 14 stations in Daxing District, Hedian District, and Shangyi District of Beijing. Let's look at the application of autonomous driving in the sanitation field. First, let's watch a video.
这些无人驾驶环卫车每辆都装备了5支16线激光雷达，并配合多个工业相机、超声波雷达、毫米波雷达等，可实现360度无死角覆盖。全车的豪华感知配置能将识别道路与物体的时间控制在50毫秒以内，地图的定位精度达3厘米。通过实时地图、智能路径规划等技术，可在无 GPS 工况下安全运行。
The sanitation field is a labor-intensive industry. High costs, chaotic processes, poor quality, and high risks have always been the pain points of the sanitation industry. Through this video, we can see that the driverless sweeper realizes fully automatic, full working, condition, refined, and high efficiency cleaning operations by autonomously recognizing the road environment, planning routes, and automatically cleaning. Let's take a look at the unmanned mobile retail vehicle that can provide many conveniences for our lives. Driverless technology allows physical retail stores to break through the previous regional restrictions, break the boundary between offline tangible scenes and online intangible scenes, and realize the comprehensive upgrading of the retail format. In addition to the above-mentioned application scenarios, autonomous driving technology has also been transformed and applied in fields such as ports, terminals, and mining. At present, the commercial landing of driverless technology in China is still in the initial stage, although it has been deployed in many fields. There is still a long way to go before fully realizing commercial application. With the development of technologies such as environmental perception, high-precision maps, path planning, control algorithms, and the Internet of Vehicles, it is believed that the commercial landing of driverless intelligent vehicles will gradually be realized from low speed to high speed, and from closed and limited scenes to open routes. Okay, today's course is here. Thank you, everyone. Goodbye.